Astronomers now know that virtually every star in the night sky has at least one planet orbiting around it. And they believe that many of these planets could harbor life. Here's the problem. The planets are orbiting extremely bright stars, sometimes billions of times brighter than the reflection off the planet. But if you can block just the light from the star, all of a sudden you can study the planet in more detail. Let's go figure out how to block a star's light on this episode of Crazy Engineering. All right, we're here with Nick Siegler in this very fun-looking lab. Nick, can you tell us a little bit about where we are?
Mike, we're in JPL's Starshade lab.
What exactly is a starshade used for?
Mike, there are two techniques that NASA is advancing to look for life on exoplanets. The starshade basically is a large shade that is flown outside of a telescope with the intention of blocking the light of the star. So then we can see the planet's light skirt the shade and captured by the telescope.
Okay, so this is much like I'm looking up at the sun and I want to see a bird or an airplane. I put my hand up to block the sun's light, but we have to do it on a much larger scale for a star.
The starshade itself is tens of meters in diameter. That's the size of a baseball diamond.
Just about how far away from the telescope would it have to fly?
It's tens of thousands of miles. You can fit like 4 Earths between the telescope and the shade. It's got its own propulsion system. It's literally its own spacecraft.
How do we get it up into space?
That's the engineering challenge, is how do we get something that has to deploy to tens of meters in diameter that could sit on top of a rocket? So now our engineers have come up with a technique based on the ancient practices of origami.
Sounds difficult. How do you know that's going to work?
Well, we do what we always do. We start small and we work our way up. So we started in this case with something just a few inches in size. Then we built something a meter in diameter, and we matured up to 2 meters. And now we finally got up to 5 meters. The one that flies in space is going to be tens of meters.
Okay, so you're using origami to make this really large starshade. It's a fun mechanical engineering project. But you mentioned that NASA is actually investing in 2 different technologies. What's the second technology?
That one is called the Coronagraph.
The Coronagraph. Can we take a look at that one?
Let's go.
Okay, Nick, this is obviously a lot different than the last lab we were in. We're in bunny suits now, we're trying to be super clean. Can you tell us where we are right now?
Mike, we are in JPL's high contrast imaging testbed lab. This is where we test the next generation space coronagraphs. Behind us is one of our vacuum chambers where we simulate the environment of space.
What's the big difference in approaches here?
With the starshade, we saw that the blocker was way outside of the telescope. Now, as another approach, we're going to take that huge blocker and shrink it down to the size of something that could fit in between your fingers. This way, it can fit on the back end of a telescope. This particular mask is the size of a pinhead. All of that starlight has to be focused right onto that little pinhead. We want to make sure that the focused light from the star hits the sweet spot of the mask. So it's critical that we have a mechanism to control the focused light.
All right, we saw the starshade and now the coronagraph. They're both crazy in their own ways, and it's a lot of really great engineering. So what's the end game? What do we hope to accomplish?
Mike, we're trying to develop the technology to be able to look for life on other planets. The hard part is blocking the light from the star. Once we do that, we have other technologies that are much more mature and will be in a better position to look for evidence of life.
Nick, thank you so much for showing us both of these approaches in both your laboratories. We really got a sense of the contrast between the different approaches. Hope you guys out there had a lot of fun learning about it, and check back soon for some more crazy engineering. If you guys like that, you can click over here to watch more crazy engineering, or click here to subscribe to the JPL YouTube channel. If you want to learn a lot more about what JPL is up to, click this link down here.